Welcome to this video all about problems involving the mean average. Be sure to check out the PDF file with all the questions, clues and solutions on mathsupgrade.co.uk. Most of the questions here are non-calculated questions. Starting with question 1, which for 3 marks tells us that there's 10 boys and 20 girls in a class. We're told that the class has had a test and the mean mark for the whole class is 60. The mean mark for just the girls is 54. We need to work out the mean mark for the boys. So the trick with all these questions is to work out the total for the whole class. So since the mean for the whole class is 60 and there's 30 people in the class, then since we know that the mean is the total divided by the number of values, we can find the total by doing the mean multiplied by the total number of children in the class. So 60 times 30 gives us 1,800. So the total for the whole class is 1,800. In a similar way, we can find the total for the girls. The total for the girls will be the mean mark times the number of girls. So 54 times 20, which without a calculator, you can just do 54 times 2 times by 10. That gives us 1,080. Now, if I subtract these two numbers, that'll give me the total for the boys. So the total for the boys must be 720. And we know there's 10 boys in the class, since it tells you in the question. So the mean for the boys must be 720 divided by 10, which is 72. And that's 3 marks for that question. In question 2, we're told there's 20 men, 10 women and 10 children in a competition. The mean score for the women is 15.6. The mean for the children is 9.2. Kevin says the mean score for all 40 people is 11.2. So if that's true, we need to work out the mean score for just the men. So again, with these questions, I'm just going to underline the key information. I'm just going to note the mean is the total divided by the number of values. So given that, then we can find the total for the class, because we can just do the mean for the class times by the total number of people in the class. So we can do 11.2, which is the mean for all 40 people, times by the total number of people, which is 40. So to do this, you can just do 11.2 times 4 times 10, which gives us 448. In a similar way, the total for the women is the mean for the women times by the number of women. So that's 156. The total for the children is 9.2 times the number of children, 10, which is 92. So we could find the total for the men by subtracting the total for the whole class, the women and the children. That gives us 200. Then, since now the number of men is 20, 200 divided by 20 gives us the mean, which is 10. And that's 3 marks for that question. The second part of the question tells us that Kevin is wrong. The mean score for all 40 people was actually 11.15. How does that affect the mean score for the men? So, if you remember here, we use the mean score for all 40 people as being 11.2. So if the mean score for all people for the whole class is going to be slightly less as 11.15, that means the total for the whole class is going to be slightly less. So that means the total for the men will be slightly less, which means the mean for the score for the men will also be lower. So that's 4 marks there for the whole question. In question 3, we're told that a class is given a test. 10 girls in the class get a mean of 70%. The 15 boys in the class get a mean of 80%, so there's more boys than girls and they get a higher average mean. Nick says that because the mean of 70 and 80 is 75, then the mean for the whole class is going to be 75%. So we're told is not correct, but we need to work out whether the mean will be less than or greater than 75%, and we've got to justify our answer for 2 marks. So the important thing here is that there's different numbers of boys and girls. They're not equal amounts. If they're equal amounts, then the mean would be 75%. But they're not equal amounts. There's more boys than girls. So the boys' mean here will have a greater effect on the whole mean of the class. So my answer here is that the mean will be greater than 75% since there's more boys and their mean is higher than 75%. And that's your 2 marks for that question. Question 4. There's 4 red bricks that have a mean of 5, 5 blue bricks have a mean weight of 9, and 1 green brick has got a weight of 6. So Donna says the mean weight of all 10 bricks is less than 7 kg. Is she correct? And show how you get your answer. So what we can do in this question is, like we've done in previous questions, we can use the fact that the mean is the total divided by the number of values to find the total weight of the individual groups of bricks. So I can find the total of the red bricks and the total of the blue bricks. So the total of the red bricks is just going to be the mean of the red bricks times by the number of bricks. So there's 5 kilograms as a mean, and there's 4 red bricks, so multiply those together, so we get a total weight of 20 kg for the red bricks. Similarly, we get a total weight of 45 kilograms for the blue bricks. Now the mean of all the bricks is going to be the total weight of all of them divided by the number of bricks there are. Since I can find the total weight now, I can find the mean. The total weight is going to be 20 plus 45 plus the green brick. There's 1 green brick with a weight of 6. Add those together, I'll get 71 kg. Divided by 10 is 7.1 kg. So clearly she's wrong, because the mean weight is going to be slightly above 7 kg, and that would be 3 marks. In question 5, we're told that we've got a basketball team. At the end of 11 games, the mean score was 33 points per game. At the end of 10 games, the mean score was 2 points higher. So Jordan says that the team must have scored 13 points in their 11th game. Is he correct? And show how you get your answer. So again, like with previous questions, we're going to use the fact that the mean is a total divided by the number of values. So we can find the total number of points after 10 games and after 11 games. So let's find the total after 11 games. So that's going to be the mean, which was 33, times the number of games they've played, which is 11. That's 363. Similarly, the total after 10 games is going to be the mean, which is 35, because it's 2 points higher than that, times 10. That's 350. So we can see after 10 games they had 350 points, after 11 games they had 363 points. So in the final game they must have scored 13 points. So Jordan is correct, and that's 3 marks. In this question 6, we're told that Mark's got 18 bags of counters and 12 boxes of counters. The mean number of counters in all 30 bags and boxes is 14. The mean number of counters in 18 bags is 10. Mark says the mean number of counters per box is 4. Is it correct? And show how you get your answer. So like with previous questions, we're going to use this formula here. I'm going to rearrange it to get the total. The total must be equal to the mean times by the number of values. So we can use that to find the total number of counters. Since there's 30 bags and boxes and the mean is 14, if you multiply those together, you get 420. You can use the column method for that. Now just thinking about the bags, there's 18 bags and there's 10 as a mean, so 18 times 10 gives 180. So now if we subtract these, that'll give us a number of counters in boxes. That's 420 subtract 180, which is 240. If I divide that by the number of boxes, which is 12, that gives us a mean. So 240 divided by 12 is 20. So Mark is wrong. The mean is 20. It's not 4. And that question there is 3 marks. This is the final question in the booklet, and it's a calculator question. The manager of a clothes shop recorded the size of each dress sold one morning. So here's the sizes here. The size of dresses are always even numbers. The mean size of the dresses sold that morning is 15.3. The manager says the mean size of the dresses is not a very useful average. Explain why the manager is right. So the problem with the mean is it's 15.3, but you cannot get a dress which is in size 15.3. So given that, obviously the manager may not know whether to order dress size of 16 or dress size of 14, right? So that's basically what I've put here. Dresses are not available in size 15.3, so it's not a useful number. So part 2, which is a more useful average for the manager to know, the median or the mode? You must give a reason. Well, if you find the median is 15, right? That's the middle number, right? The mode would be the most useful, since the median again gives us an odd number size. The median gives us a size of 15, which you cannot order dresses in size 15. Whereas the mode would give us definitely either give us 14 or 16 or 18. So the mode in this case gives us 14, which is something that the manager can order. So that question there was 2 marks. So that's the end of this booklet. Thanks for watching. If you struggle with any of these questions, be sure to check out the solutions as a PDF on mathsupgrade.co.uk, and I've got more videos on this channel. Thanks for watching.